Hello again, it's Mrs. Trombley. It's time to learn how to multiply polynomials. You've learned how to add and how to subtract them, and now multiplication. There's actually several ways to multiply polynomials, but rather than confuse you by showing you every single one, I'm going to show you the most commonly used method. It's called the FOIL method. So not only is it the most commonly used, it has the coolest name too, right? FOIL. What does it mean? FOIL stands for first, outside, inside, and last. And again, it's helpful to keep change before you start any of this. So here's what FOIL means. You're going to be given two polynomials, well, two binomials this is going to work for. When you have two binomials that you're multiplying together, the F in FOIL stands for first. So I'm going to put an F here. And by first, I just mean the first number in each binomial. We want to multiply those. So when you multiply x by x, you get x squared. Next, it says multiply their outer terms. Outer stands for O. And when I say outer terms, I'm talking about the terms that are on the outside of the problem. So this is on the outside, this is on the outside. And when you take x times 2, don't write x times 2. The best way to say that is 2x. The I in FOIL stands for inner. So now we're talking about these terms on the inside of the parentheses, next to one another. These are outside, these are inside. 1 times x is x. Any number times 1 is itself. And then finally we are going to multiply the last terms. And 1 times 2 is 2. And this is all addition going on here. The last thing you do is you put them all together. So putting them together means we're going to add them together. So this is where being able to add monomials is very helpful. Combine like terms, aka combine like terms. Highest degree I want to start with, x squared. So that's the beginning portion of my answer. And then I see that I have a 2x and an x. When you take 2x plus x, yep, you get 3x. In case you're wondering where that 3 came from, this really means 1. And then we're finally left with a 2. So the quantity of x plus 1 times the quantity of x plus 2 gives you x squared plus 3x plus 2. And why did we have to do all of that? Well, because things aren't in simplest form when they contain parentheses, so it's not allowed. Oh, I forgot to put an L here. FOIL. Put them all together. Another way you can look at this is you're just distributing this x to the x and the 2. So when you distribute it to this one, that's the first. And when you distribute it to the next one, that's the outside. And then I need to do the same thing with this 1. I'm going to distribute the 1 to the x, that's the inside, and then the 1 to the 2, and those are the last. So FOIL is really another thing you could call it is double distributing. You're just distributing one term at a time because there's 2 numbers next to the parentheses instead with an addition sign. 2 terms next to the parentheses, I should say. So let's try this. Let's try a little bit of FOIL. And yes, there are quite a few examples, but hopefully they will go fast, like lightning. Zoom in on this, and okay, we're good to go. Get my blue pen, my other blue pen. I have lots of blue pens. So first off, I see these are both addition. So I'm going to do the first in the FOIL. I multiply the first 2 numbers. What's y times y? Y squared. And it's all addition, so I'm going to put an addition sign. And now I'm supposed to do next the O, which is outside. Y times 1 is y. There's your addition sign. Then I want to do the I, so the inside, 4 times y is 4y. And then the last, 4 times 1 is 4. And now at this point, all you need to do is combine like terms. Put them in standard form, of course. So y squared, that's the highest degree. There are no other y squareds. I'm going to bring it down. Then I see I have a y and a 4y. 1y plus 4y means 5y. And then we have this plus 4, this lonely little plus 4 that has no one to hang out with. And that's it. We're done. All right, next one. And instead of looking at this one as FOIL, I'll look at this as double distributive. It's just a different way to look at it. It's not a different way to solve it. I'm going to keep change. Okay, so right now I want to distribute the z to both of those terms. So z times z is z squared. It's all addition, so I'm going to separate them with addition signs. Z times 6 is 6z. Now, I want to distribute this -2 into both of those. -2 times z is -2z, and -2 times 6 is -12. Then we're going to put them all together. I have this z squared. There are no other squared terms, so I'm going to bring it down. We have 6z and -2z. That makes 4z. And then I just have this plus -12 or -12. Either one is acceptable. All right, keep it going. If you want to, you could pause and you can try to do C and D on your own and then unpause it and see if you get the same answers. I wouldn't recommend doing the whole rest of the notes because we've got a little bit more to do, more than just binomials, but hopefully you've paused me. Welcome back. Okay, let's see if you were right. I'm going to keep change. R times 2r is 2r squared, because when you multiply the same base, you add the exponents. R times -1 is -r. -5 times 2r is -10r. -5 times -1 is 5. Now we're going to put them all together. So I see I only have one r squared there, one r squared term. So 2r squared. And then we have a -r and a -10r. That means we have -11r. Plus, we still have this 5. Did you get it right? If you wrote -11, good for you. That's great. You're writing it exactly the way you should. Either one of those is acceptable. All right, last one of this type. We have 2x plus 1, and we have 3x minus 5. Keep change. I'm going to distribute the 2x first. 2x times 3x is 6x squared. Don't forget about the squared. I know that the 2 times the 3 is a 6, but remember x times x is x squared. All right, then I have 2x times -5. That means -10x. Now distribute the 1. 1 times 3x is 3x. 1 times -5 is -5. Put them all together. 6x squared is all alone. Then I have a -10x and a 3x. When you combine them together, -10 plus 3 is -7. Or I can write -7x, same thing. And very last, we have this -5 all by itself. Lovely. All right, now just when you thought, wow, that is so easy. This is great. Can we be done? We're not quite done. The next part isn't too bad, though. Take a look here. Now, we're going to have, let me get this on here. There we go. This is different because I don't just have a binomial and another binomial. I have a binomial and a trinomial, okay? It's not that bad, I promise. Keep change this to start. All we're doing is we're going to distribute b to every single term, and then we're going to distribute the -3 to every single term, and then we're going to put them all together. So let's start with the b. We're going to take this b and multiply it by b squared. B times b squared is b cubed. And we already changed it to all addition, so we're separating our terms with addition signs. B times 2b is 2b squared, because b times b is b squared. B times -7 is -7b. Now let's take care of this -3. I want to distribute -3 to all three terms. -3 times b squared is -3b squared. Oops, I wanted to put that down here. Sorry, I don't have my whiteout pen with me, so I'll scribble it out. Oh, you know that's going to drive me bonkers. It's all right, I can take it. -3 times 2b, that would be -6b. I'm sorry, -3 times 2b. I think that's what I said. And a -3 times a -7, that's a positive 21. And see, if you weren't keep changing, do you see how we could have possibly made some errors there? Yes. So now we double distributed here. We distributed the b, we distributed the -3, and now yes, it's time to combine like terms. We're going to put all this stuff together and do 2 more examples and then call it a day. All right, first off, the highest degree, the term with the highest degree is this b cubed. There are no other b cubed, so b cubed is by itself. All by myself. And then the next highest term is b squared. We're going to put those together. 2b squared and -3b squared. That means -1b squared, or just -b squared. So those are done. The next highest degree would be just these b's. And when you take -7b plus -6b, you get -13b. 13b. And now this little 21 is all by its lonesome. So right here, that's the simplest form of it. That is how you rewrite this without the parentheses. So we're just going to do 2. Again, if you think, I got this, I know what I'm doing, hit pause and try it on your own, and then unpause it and see if you got the right answer. Welcome back. All right, let's distribute this x. X times x squared is x cubed. X times 5x is 5x squared. And x times 8 is 8x. All right, then I'm going to distribute this 2. 2 times x squared is 2x squared. 2 times 5x is 10x. And 2 times 8 is 16. Now, we need to put them all together. Highest degree would be this x cubed, so I'm going to rewrite this, x cubed. We're done with that one. The next highest degree are the x squareds. 5x squared plus 2x squared, 7x squared. And then the next highest term I see is just this plain old x. Doesn't hang out with anybody. And neither does this little 16. Believe it or not, this is simplest form right here. Oh wait, it's not, because I forgot about this 8x right here. Sorry about that. 10x plus 8x is 18x. I mean, oh, I did that on purpose to see if it would catch it. Not really. Sometimes I go too fast. It happens. But anyhow, this should be right now. Is this right now? Is it? Are you sure? Do you promise? All right, next one. X times x squared. Ooh, let me change that. X times x squared is x cubed. X times negative 3x is negative 3x squared. X times negative 2 is negative 2x. Now I want to distribute this little 5. 5 times x squared is 5x squared. 5 times negative 3x is negative 15x. And 5 times negative 2 is negative 10. We're going to put them all together. I'll try not to mess it up this time. Let's see if I can do it. We have an x cubed. And as far as the x squareds go, I see a negative 3x squared and a 5x squared. So that's 2x squared. Those are done. I see negative 2x and negative 15x. That's negative 17x. And then there's this little negative 10. And again, if you wanted to rewrite this, we could rewrite this as x cubed plus 2x squared minus 17x minus 10. What do you think? We're good? All right, one more little example. It's the story. Well, I guess it's just the application. There's not really a story. One day there was a lonely rectangle, and we had to find its area. I don't know what else to say. So, I want you to write a polynomial for the area of the rectangle. Area is length times width, right? So, it just so happens that instead of this being 20 by 10, it's the quantity of 2x plus 20 and the quantity of x minus 40. To find the area, I just want to multiply the length times the width. So we're doing kind of the same exact thing that you did back in the day. We're just multiplying length by width. So let's zoom out a little bit so you can see everything. Here we go. In order to figure this out, we have to take length times width. Now if I wrote x minus 40 on the other side and 2x plus 20 on the other side, it wouldn't matter. It's okay. Multiplication order doesn't matter. When you distribute it, it'll end up being the same exact thing anyhow. All right, we're going to add the opposite in here, and now it's a binomial multiplied by another binomial. I can FOIL it. So I'm going to multiply the first two numbers, 2x times x, that's 2x squared. And then I'm going to multiply the outside numbers, 2x times negative 40, that's negative 80x. Now the inside, 20 times x is 20x. And last, 20 times negative 40. 20 times negative 40, what's that? Well, I know that 2 times 4, that gives me negative 8, and we have 2 zeros, right? Okay, here we go. Like terms, we have 2x squared. It has no one to hang out with, so I'm going to rewrite it as that. I see a negative 80x, and I see 20x. When you add those together, we get negative 60x, and this little negative 800, it just gets to hang out all by its lonesome. I know, it's very, very sad. Okay, so right there, that represents the area of the rectangle. And now it says, find the area when x equals 60. So we just wrote this expression, right? That's the expression that we figured out. That represents the area of it. Now, all we need to do here is plug in 60 for x. This is going to be a whopper, I think. Plug it in. Plug it in. Now I'd probably get my handy-dandy calculator out. Go ahead, you type it in, I'll type it in. You'll probably beat me because whenever I try to hurry, I end up messing something up. It's the truth. Do you ever do that? I'm trying to stall you, buy myself extra time so I can win. Not really. All right, when you entered all that in, I'm hoping you got the same thing that I did. I got 2,800, and we're measuring in feet, and didn't we just find area? So guess what measurement I have to do? I have to do feet squared. And now you're done. I'll see you tomorrow.